이번 주에 숙제 괜찮았어?
맨 마지막 것들 전 이해 안 가는 게 몇 개 있었어요.
맨 마지막 것들. 오케이. 맨 마지막 거 어려웠던 거 좀 많았어. 자, 일단 첫 부분부터 unit fraction exponents. Converting from radical to exponential or vice versa. 이 부분 괜찮았지? 괜찮았나? 첫 번째부터 해보자. 이거 살린이부터 시작해보자. 이걸 exponential form으로 바꾸면
B 4/9.
b to the 4/9. 맞았어. 다음 거 바로 해보자. t to the 5/8 and radical form is 도경할 걸 했어? 아이고, 도경이 말고 지원아 이거 풀었어?
네,
이거 뭐 나오는지 알려줄 수 있어?
I got root 8
Okay, root 8
and t to the power of 5.
t to the power 5. Nice. Okay, and moving on, 8 t to the 7th. 이건 시우가 해보자.
Z
Z?
to the Z 7/8.
Z 7/8. Yeah. 이 부분 괜찮았지? 이거 세 문제만 풀고 바로 넘어갈게. To properties of exponents. 첫 번째 문제 보면 y to the 3/4 times y to the 1/3. 이건 민혁이가 해볼까?
이거 y
Mhm.
to the 13/12.
13/12. Nice job. And the next one is 아이고. 왜 이러지? 잠시만. The next one is a to the 5th over a to the 5/2. 이건 예지가 해보자.
Is it a and 5/2?
A and 5/2.
Yeah.
Correct. Let's move on to the next question. This one's a bit more harder. 4 or y/5 and to the half power. 이건 살리니까 해보자. 다시.
Is it 4y to the 5/8?
4y to the 5/8. Okay. So close. So when we do this problem, remember 4 is the same thing as 4 to the first power, and y we convert it to 5/4, right? So when we multiply the half, it also multiplies the 4, not only to the y. So 4 to the half, which is the same thing as 2. So our answer should be 2y to the 5/8. So
Oh.
we have to do it to the numbers as well, because they also have exponents. But other than that, you're right. The next question is 3 4z times 3z to the 3/4. 이건 지원이가 해볼까?
I got 9z.
9z. I think that's right, just 9z. And the next one, 5z4 times z negative 3/2. 이건 시우가 해볼래?
Z to the half.
z to the half,
Yes.
2.5. Did everyone else get z to the half? I think that's right, yeah. Z to the half should be correct. And let's do one more problem from this section. Let's do this problem. 10 3z over 2z squared. 이건 민혁이가 해보자.
5 z
Five.
to the 5/3.
5/3. Okay. Did everyone else get this answer?
Could you explain how to do that one?
Okay, I can explain how to do this. Okay, so 5 is right, 10 divided by 2, but we have to convert these two, right? We have to convert the radical form into a fraction form. So if we rewrite this, it becomes z to the 1/3 over 2z squared. And how do you do this? Well, we're subtracting. So it's z 1/3 minus 2 equals negative what? 5/3, right? So don't be afraid to have a negative. You can actually write this as 5z to the negative 3. Remember, if exponent is dividing another exponent with the same base, you can subtract. So it's the same as this, which we got as z to the negative 5/3. Does that make sense?
Yes.
Okay. So let's move on to the next section. Our next section is evaluating radical expressions. So our first problem. Actually, let's do this problem. 3 to the negative 54 times 3 to the half. Let's do this problem. 이건 예지가 해볼래?
Is it -3?
Negative 3, okay.
Yeah.
Yeah, it is negative 3. Did everyone else get negative 3? This one's a bit tricky, so does anyone need an explanation for this problem? Or everybody got this right?
I guess, can you do it?
Okay, so let's look at this problem. 3 to the negative 54, remember we want to change it to fraction form. So let's do that as the first step. Negative 54 to the 1/3, right? And this half, so half to the 1/3. And now we have the same exponents here, but we have different bases. Remember the
And you leave the exponent outside and just multiply the numbers, right? Like the bottom.
right. You factor the exponent, right? Not really factor, but you can rewrite this as negative 54 times half to the 1/3, since 1/3 is distributing inside. Negative 54 times half is negative 27 to the 1/3. And negative from here, we know that 27 to the 3rd is 3, because 3 times 3 times 3 is 27. But negative 27, since it's an odd number, we can actually do this. Negative 3 times negative 3 times negative 3 is going to be negative 27. because this is positive 9 multiplied by another negative 3 is going to be negative 27. So our answer here is just going to be negative 3. Make sense?
Yep.
Okay. Let's move on. Okay. So now we have some word problems. Well, yeah, kind of word problems. Our first question, actually, let's do this question. 1/7 to the x power equals a negative 9x. And we want to find the value of a that makes it true for this, right? So we're given 4 options, A, B, C, and D. Salina, what did you get for this one?
I didn't get this one.
Okay. Did anyone get an answer for this one?
I got B.
B, okay. We have one for B, which is 1/7 to the negative 1/9. Anybody else? Or let's try solving this one then. Okay, so we have to find the value of A so that this is true. Let's see. We're given 1/7 as our base. So let me rewrite this out. Like this. Okay, so we're given 1/7 as our base here. So for our answer choice, it should also have a base of 1/7, right? And then we can match the exponent later. So if we look at our answer choices, A, B, and C all have a base of 1/7, and does not. So we can rule out D. Let me just write that down. Okay, we can rule out D. And from these 3 choices, now we look at the exponents to see which one would fit just x. Well, negative 9, this is just x. So negative 9x multiplied by something has to equal just x, so that the exponents are the same when we put it in here. So what number can we do? Well, if we want to find out what this missing box is, we just divide negative 9x on both sides, right? Which leaves negative 1/9. So we know that our base should have a base of 1/7, and our exponent should be negative 1/9, which leaves answer B to be right. If we plug it in the equation, like that, negative 9x, we see that negative 9x multiplies with negative 1, leaving 1/7 and x, which is the same as this. So B is correct. Make sense? Or still confused?
Makes sense.
Makes sense? Okay. Let's move on. Okay, let's do the next one. What is the value of A when we rewrite the expression 29x over 2 as a to the x? And we're also given A, B, C, and D. 유겸이 들어왔네. 유겸아, 너가 이거 해볼래? Were you able to solve this one, or?
No, I was kind of confused at this part.
Okay. That's fine. Did anyone solve this problem?
B.
B, okay. We have another B. Let's see if B is correct. So we want, just like the same as the last question, we want A of X to be the same as this, right? So we can get equal to each other. And in this case, we also have a base of 29. So obviously we want a base of 29 here, which rules out A and C. This has a base of, what is that? 14.5, and this has a base of 1 over 29. So it's either gonna be B or D, but if we look at the exponent then, we want the exponent to be x over 2. So x multiplied by something has to be x over 2, since we're multiplying the exponents once we put in our answer choices in. So how can we solve for that? Well, we just divide x on both sides again. And if we do that, x over 2 over x is going to equal half. So our exponent should be half. Our base we figured out was 29, and our exponent should be half, which leaves B as our choice. So B is correct. Let's move on to the solving exponential equations part, because I would assume that was the hardest part. Let's try the second problem first. 2 to the 9x plus 2 equals 16 5x minus 2. 이건 지원이가 해보자.
이거 잘 어떻게 하는지 몰라서 못 풀었어.
Oh, 그래? Okay. Was anyone able to solve for x? Or did everyone have a hard time?
10 over 11.
10 over 11. Okay, x equals 10 over 11. Anybody else? Well, let's try this, shall we? So we're given 2 9x plus 2. Actually, I won't rewrite the problem. So our first step here is we don't have the same base. We have a base of 2 here, while we have a base of 16 here. So it's very hard to work with different bases, because if we remember our properties, if they all work when we have the same bases, unless you're multiplying exponents, which doesn't really matter. But usually you want the same base to work with each other. So how can we change this? Well, 16 we know 2 times 2 times 2 times 2 is 16, isn't it? Right? In other words, 2 to the 4th is the same thing as 16, right? So can we write 2 to the 4th instead of 16? Can we replace this? I think we can. So if we rewrite this, we can essentially write this, because 2 to the 4th is the same as 16. Okay, now we're working with same bases, so it's much easier to solve. Using our multiplication rule for exponents, we can multiply our exponent to this exponent, which gives us 2 to the 20x minus 20. Okay, now from here, this has a base of 2, and our exponents are different, or are differently written. And we know that this side has to be equal to this side, which means that this exponent has to be equal with this exponent, right? So we can set the exponents equal to each other. 9x plus 2 equals 20x minus 20, and just solve for x. If we move 9 on the other side, it becomes 11x. And if we move 20 on the other side, it becomes 22. So if you divide 11 on both sides, it
Uh,
comes
isn't it 20x minus 8?
oh, is it 8? 20x minus 8? Did I write the question wrong? Isn't this a 9x? Wait,
Or for 2, the 2 and then to the power of 20x minus 20.
oh, right, you're right. 2x, oh, good catch. Okay, so 20x minus 8. 4 times negative 2 is negative 8. I don't know why I wrote negative 20. Okay, let's change our equation then. That's negative 8, which means that this number is going to be 10. So 10 over 11 is correct. Make sense? Or good catch on my mistake. That was good. Should we move on to the next question? Or does anyone still have questions left? Nobody? Okay, let's move on to the next question. Next question is 7 to the negative 9x plus 1. And that is equal to 49 to the negative 12th power. 시우가 이거 해보자. What did you get for x?
I got 25 over 9.
25 over 9, okay. Let's also try this problem because I feel like some people are confused. 7 to the negative 9x plus 1. Remember, our first step is to have the same basis. So we can change 49 to 7 squared, right? Because 7 times 7 is 49. So we can rewrite 7 squared in place of 49. So negative 12. And let's try this. Our multiplication rule tells us that 7 negative 9x plus 1 is equal to negative 24. And since we have the same basis, we can set the exponents equal to each other. Negative 9x plus 1 equals negative 24. And just solve for x. If we do that, we get x equals 25 over 9. So 25 over 9 is correct. Okay. Anybody still have any questions? Or you guys are totally good on this? Oh, you guys must be.
I think it is now like better.
Okay. Let's try one final problem. Let's try a division problem. We're given 81x plus 5 all over 3, 7x plus 2 equals 3x minus 2. 이건 민혁이가 해보자. What did you get for x?
I got x equal 5.
X equals 5, okay. Let's try this. So we have two same bases here, but we have a different base here. 81 is a very big number, but I think 3 to the 4th is the same as 81. 3 times 3 times 3 times 3 is 81, in other words. So we can change 81 in place of 3 to the 4th. So if we rewrite our question, 3 to the 4th, x plus 5 all over 3, 7x plus 2 equals 3x minus 1. And now once again, we just simplify. 4 times x plus 5 is going to be 4x plus 20. I'll just cross it out. And here we can use our subtraction property. So when we have the same basis, we can subtract the exponents. So 4x plus 20 minus 7x plus 2 is gonna be negative 3x plus 18. That's at 18. So if you write the whole question, negative 3x plus 18 is going to be 3x minus 2. Once again, we have the same basis with nothing else in the equation. So we set the exponents equal to each other. And if we do that, negative 4x equals negative 20, we get x equals 5. X equals 5 is correct. Okay, I think that's it for homework today. Does anyone have some final questions on homework? Anything that's confusing or doesn't make sense? Nope. I guess let's move on to our lesson. So we're doing logarithms today, which I think might be a bit hard since it's a concept that you usually don't study. So logarithms, the way I like to think of it, log, or other words log, is the opposite of exponents. So there's multiplication, and that's like the total opposite of division, right? And there's addition, and that's the opposite of subtraction. The same way, I think logarithms are the total opposite of exponents. So how are logarithms written? Well, logarithms. Have you guys seen this shape before?
No.
No? So it's a new concept to all of you guys, I guess? Okay, so if I were to explain logarithms and how they're opposite of exponents, when we look at exponents, for example, let's think of a case 4 to the x power equals, let's say 16. Okay, simple. This is an exponent form problem, but how can we change that to logarithm? So in exponent form, this is called our base, the biggest number, or the the number that the exponent multiplies itself to, right? But in logarithm form, this is called our base, this tiny little number. So in the same way that this is a base and this is a base, when we rewrite this as logarithm form, our base goes here. So this 4 goes into the base portion of the logarithm form. And this part is where our answer goes, or what it equals to in the exponent form. In this case, it's 16. And this part is where our exponent goes. So it's just x. So when we rewrite this exponential form, we can rewrite it in log form as log to the base 4 of 16 equals x. And we solve for x. Well, we know that because this is a pretty simple example, we know that x equals 2, which means this complicated thing is also equal to 2. Well, this was a simple example because we know the exponent, right? We know the exponential form. So we use this form when we can't really solve it in exponential form, or I can't really think of other applications, but that's when we usually use this form. We change it into logarithm form so that we can solve it this way. A lot of things you'll see is that you'll just see, for example, log 4 or log 5. What is log 5? And in this case, you might wonder, well, we don't have a base, right? We don't have a number underneath telling us how to solve this. How can we solve this without a base? Well, log 10 4, log 10 of 5. This is the exact same thing as just log 4. We don't write the 10 because it's something that is unnecessary, just like how we don't write x to the first power, right? We don't write that because everyone knows that just x is just x to the first power. So if there's no base written, everybody knows that it means that it's to the base of 10, because 10 is the number that we work with the most. And now, how do you actually solve it, right? How do you actually solve logarithms? Well, the good news is that you'll probably solve logarithms using a calculator. So if you guys have a calculator, do you guys have a scientific calculator?
Yes.
Okay. Well, in the scientific calculator, there's an option where you can choose log, and all you do is you press the log button, and sometimes it will only give you this box to fill in. But in some other calculators, you can fill in both bases and numbers like this. And that's how you basically solve logarithms. Or at least that's how you solve logarithms that are hard, which are usually very hard to solve. But today we're gonna solve logarithms by either changing it to exponential form or, yeah, by changing it into exponential form. So before that, I want to introduce some properties of logarithms. So if we have a base a per se, and let's say we have a term, two terms in place, x, y, then we can rewrite this so that the term inside split. So when two terms are multiplying with each other inside the logarithm, then we can change it into two logarithms where each term is separate from each other. That's called the product rule. You'll have to probably memorize it. And the same way, x over y, it's kind of simple because we all did this while we were doing exponents, right? It's kind of similar. They're multiplying with each other, you add them. If they're dividing with each other, you can subtract them. And probably the most important one is if there is a logarithm and it's to the power of something, then you can take the power and bring it out. So it's p times log to the a to the x. Do these three rules make sense so far? We'll go over them while we solve problems. But hopefully you memorize. I mean, you'll slowly memorize it and then you'll slowly get used to these three functions. Let's do a practice problem. Log 2 to the 64. How do we solve this? Well, oh, I forgot to do one important rule. I'm sorry. When we have a base and a number that are exactly the same, so for example, log 2 to the 2, this whole thing is just 1. For example, let's do log 4 to the 2 squared. This is just 1 because let's look at this example. If we change it into exponential form, our base goes here, this 1 goes to our exponent, and this number goes outside. See, 2 equals 2. So when we have the same numbers in our logarithm, we just look at it as 1. Knowing that, let's try a problem. Log base 2 to the 64th. How do we do this? Well, sort of like exponents, we want to change this 64. What is 64? 2 times 2 times 2 times 2 times 2 times 2, I think, is 64. So 2 to the 6th, I think, yeah, 2 to the 6th is 64. We want to match this base so that this number, so that it fits here. If 2 to the 6th is 64, we can just write 2 to the 6th instead of 64, right? So we can rewrite this problem as this. And now, how do you do this? Well, remember that we said this is equal to 1, right? And if we use a property of exponents, we said if it's to the power of something, we can bring it to the front. So we can rewrite this as 6 times log 2 to the 2 equals something. We can rewrite it as this. And we said this is just 1, so we don't really need it. So to answer this logarithm, it's just 6. We're just left with 6. Confused? Or makes sense?
I'm a
Kinda
bit
confused.
confused.
Confused? Okay. Let's try one more problem. Let's try a couple of problems actually. Let's take log 9 to the 729th power. 729. Wow, this is hard. 81. So it's 9 cubed. 9 times 9 times 9 is the same as 729. So we can replace 729 with this exponent. So if we rewrite this, log base 9 to the 9 cubed, we can rewrite it as that. So now how do we solve it? Well, remember our 3 properties? Our first one was the product rule, and our second one was the quotient. Well, and our third one is the one where it said log a, let's say x to the p power is the same as p times log a to the x power. So we take this exponent and bring it out front. So in this case, we can take 3 and bring it out front. So it's 3 times log 9 to the 9th power. Is anyone lost so far?
I get it.
Okay, let's move on then. Log base 9 to the 9th is the same thing as 1, right? Because let's write it separately here. Log base 9 to the 9th. What is that? Well, let's rewrite it to exponent form to see what it would be. Base 9 goes here, question mark goes here, and this 9 goes outside, right? So it's asking, if we rewrite it in exponent form, it's asking 9 to the what power is 9? Well, just 1, right? It's just 1. So similarly, this whole thing is just 1. So 3 times 1 is just 3. So we're just left with an answer of 3, or 3 here. Still confused, or makes sense now? Makes a little bit more sense, I guess, or
Yeah.
okay. let's let's do this problem. Log base 16 to the half. Well, this is a bit harder, right? We can't change this number so that it matches our base. So what can we do? Well, in this case, right? Yeah, we can't do that. Well, in this case, let's see. I totally forgot how you solve this. You can change the base, I guess. Wait, give me a moment. I need to think. -2. Right. Okay, so when we have a base, when we have a number that we can't change into the base again. Wait, is this right? I'm so sorry, guys. Wait a minute. 16 half. Oh my gosh, can't believe I forgot this. 16 the half. You know, I'm gonna move on for now, and then I'll come back to this problem when I remember how to do it. I'm sorry, it's been years since I've tried this. Let's look at the properties then. So log 3 plus log 5. So we're looking at properties now, and if we look at this, we can use the product rule to just multiply log 15, right? Because 3 times 5 is 15. Since we have the same base of 10, we can use the product rule to solve this. So in this type of problem, log 10 to the 15th is something you can't really solve on your own. You can't really, you can't do it in your head or with a paper. You have to use a calculator because you'll get a decimal. So we just leave it as it is in its simplest form, in the form of log to the c power. I think I remember how to do it. Yeah. So if we go back to this problem, what was it? Log 16 to the half, right? Okay. So how you solve this problem is you change it to exponent form. So base 16 is 16. We don't know what the answer is. So let's write x here, actually, x, and half outside here. So now our question is 16 to the what power is half? Is this right? Yeah, this is right. So 16 we can rewrite as 2 to the 4th power. So if we rewrite this, it's 2 to the 4th power to the x. And here, half, we can change it. Actually, we can change this half to 2 to the negative 1st power. Does anyone know why you can do this? Why half is the same as 2 to the negative 1st power? Nobody? Okay. Well, when we have a negative exponent, like 2 to the negative third, then how you get rid of it is you bring the other side of the denominator. So it's 2 to the negative third over 1. So if you want to make this positive, you bring it down there. So it becomes 1 over 2 cubed. In the same way, half is the same thing as 1 over 2/1. So if we want it not to be in the denominator and want to raise it up to the numerator, well, we raise, but remember, if we raise it, when it was a positive, it becomes a negative this time. So half, when we raise it, becomes 2 to the negative first power. And from here, it's much easier to solve. 2 to the fourth times x is just 2 for x, and 2 to the negative 1. And in the same way, we can set the exponents equal to each other. 4x equals negative 1, which means that x equals negative 1/4. Wow, okay. I'm really sorry I forgot how to do this. But do you guys get how I solved x equals negative 1/4?
Yeah.
Okay. Let's do one more question that's similar to this one. Let's do log base 16 of 4. So we can't change the 4 so that the base matches 16 because 16 is too big of a number. So we change it to exponential form the same way. 16 to the x power, if you say x, is the same as 4. So what is 16? We want the bases to be the same, so we can change 16 to 4 squared equals 4. So 4 to x is equal to 4. 4 is the same as 4 to the first power, and we can set the exponents equal to each other. So 2x equals 1. So x equals half. Make sense? Hopefully that made sense.
Yes.
Okay, let's move on. So sometimes you have to work properties backwards. So if you see a problem like this, 2 times log to the 4th, log 4, then how should we solve this? Well, we have a 2 that's taken out here. And if we look at the third property, p, when it's taken out, we can go the opposite way, put it as an exponent. So we can write this as log 4 squared. Or, in other words, if we simplify this further, log 16. So we can work with exponents both ways, properties both ways. We don't only have to change the exponent and take it out. We can also do vice versa. And let's do one of the more simpler tools when we do logarithms. So for this section, which is called the change of base rule, you can use a calculator. I think it's fine if you use a calculator. So how we approach these problems? Log 7 to the 25. So there's nothing we can do with this problem. We can't change this so that it fits the base, nor can we change the base, change it to exponential form so that we get a nice answer. For example, if I change it to exponential form, it becomes this. 7 to the what power is 25? Well, we're not going to get a clean answer. It's going to be a decimal. So we can use calculators for these problems when we can't do it on hand. But some, as I said before, some calculators don't have an option where you can change the base. Like it's usually gonna give it in this format where you can't change the base. Since 10 is such a common base, you don't usually work with bases other than 10. So how do you solve this then, if we are going to use a calculator? Well, there's something called a change of base rule, where it says log to the base of a to the b is the same as log to the b over log over a, where these are just bases. In other words, you can take this b and this a and split it so that it's something b over a. So if we rewrite this whole problem, we can rewrite it as log to the 25th, 25 over log over 7, log to the 7th. It's the same exact problem. Now we can put it in the calculator, right? Because these are all bases of 10. That's a tool that you'll have to get really used to. But I guess if you have a good calculator and you can change the base, then you're fine. But it's still something you should really know. Like really, you should memorize. Yeah. Let's try a word problem. Actually, let's try solving exponential equation. So 7 times e 0.1 t equals 47. We're given this problem and we want to solve for t. What is t? And okay, what is t? So let's try this. Well, first of all, we have a weird thing here. It's called e. So what is e? Well, do you guys know what e is or have heard of e? In
No.
math? No, never heard of e. Have you guys heard of pi? Right?
Yeah.
Yeah, you guys should know what pi is. Well, pi is a constant, right? It's a constant that goes on forever. E in the same way is a constant that goes on forever. That's important in math. And it's around 2.71. It goes on, but 2.71 to 2.72. So this number is especially important when we do logarithms, because we have a lot of cases where our base is e, not 10. So these are our two common most cases where our base is e instead of 10. And when our base is e, let's say log of e to the 5, then in the same way as we don't write 10, we don't write e, but we write it as ln. So ln of 5 instead of log of just 5. If you do log 5, we know it's base 10. If you do ln 5, we all know it's base e. So back to our problem. We're given this equation and we want to solve for e. Let's start with dividing 7 on both sides, which leaves us with e to the 0.1 t equals 47 over 7. We can't really simplify that, so let's just leave it as it is. And how do you get rid of the e now? Well, if we multiply ln on both sides, or have it like that on both sides, like that, it's the same question as log e to the 0.1 t, right? Log e to the 47 over 7. It's the same thing, right? And we have an exponent here. Well, we can take the exponent out. So it's 0.12. And oh, look, we have a base e to the e power, or not to the e power, but to the e. And remember, we said if a base and this number is the same, it's the same as 1. So 0.1 t times 1. We can simplify this whole thing to 0.1 t, just 0.1 t, since we don't need to write the times 1. And on the other side, we're left with ln of 47 over 7. And we can divide 0.1 both sides. So t equals this really complicated thing. But we can put it in our calculator and solve what it is. Anybody got confused on this part? Or does that make sense? Did that make sense to people? Cool. Hopefully that made sense then. What else do we need to cover? Let's see. Let's try one word problem. Log, and we'll call it a day. Log base 7 to a times log b to 7. Not a word problem, but we're asked what is equivalent to this. So we don't know what this number is in this logarithm, but we don't know what our base is in this logarithm. So how can we solve this? Our answer choices are going to be log to the 7th, log to the 7a, I'll put it in parentheses, log base a to the b, log base b to the a. Does anyone have a guess on what this could be? Nobody? Okay. Well, let's look at the first problem. We have a 7. 7 as our base in the first logarithm, but in their second problem, you have a 7 as our this number. So we have 7s, but how do we solve for this? Well, we can't really simplify this, so let's use the change of base rule, where it says we can put log a over log 7 for this part. We can multiply that with, let's use the change of base rule here too, log 7 over log b. Okay, so we rewrote it as 2 fractions now, and we have log 7 and log 7. Well, we can just cancel those out, leaving log a over log b. Okay, so now what can we do? Well, we're still left with a fraction, and we don't want a fraction if we look at the answer choices. So let's see. Log a over log b is the same thing. How should I explain this? Well, how do I explain this? This is hard to explain. This is not, logarithm, changing bases. Actually, I'm gonna take this problem out because you have to change bases, which is something that I don't think, yeah, this is a bit difficult. So I don't think you guys should learn this. And only algebra 2. So I'm just going to leave that out for now. I'll take it out in the homework. But, well, that was a bad lesson for today. But I guess that's it for today. Do you guys have any other questions on logarithms? Or everyone good on what logarithms are? If that's it, then I guess that's it. See you guys.
Thank you.
Thank you.
Thank you.